The next talk we have by Austin is YARA-as-a-Service for real-time malware detection. So here is Austin.
Thanks. Yeah, so as you notice, we sadly could not stick with the name. We envisioned YARA-as-a-Service, YaaS, but we were not allowed to use that name. So it's actually now Binary Alert. And the reason we called it that is that that's similar to our Airbnb's other open source security tool, which is StreamAlert. By a show of hands, has anyone heard of StreamAlert by any chance? Oh, one. Wow, okay, cool. So yeah, this is Airbnb's second contribution in the serverless open source security space. StreamAlert and now Binary Alert for binaries. So one of the themes of the conference, one of the things that's come up a lot of times is that like security tools have to scale along with the rest of the world. So when you're designing a security tool, it has to be designed the same way that any other product would be designed. It has to be designed to scale. It has to be designed with profit and loss in mind. So at Airbnb, we're at fairly large scale and growing really rapidly. So to give you a sense, if we count all of the binaries that in some subset of our infrastructure, all of the unique executable binaries, we have currently about 2.5 million unique binaries, whether that's from laptops and servers and so on. And to exacerbate the problem, it grows at a rate of almost 1% a day, a weekday. People downloading new things and updating packages and what have you. So a large and exponentially growing base of files presents a large attack surface. And so we need a way to analyze all of those. What we'd like to be able to do is to detect if any of these are malware. Every single binary is a chance for an attacker to gain a foothold. And so what we'd like to be able to do is to analyze all of these. So YARA is the state of the art for malware analysis, and there's been a couple other talks about it. There's a really big one tomorrow about how to write effective YARA rules. So YARA is essentially pattern matching for binaries. You can think of it as sort of like a high-powered regex for identifying patterns in binaries. So as an example, this is a YARA rule that we'll actually be including with Binary Alert when we open source it at the end of the talk today. And so a rule has first metadata about arbitrary key value pairs you can describe in the rule. And again, more talks tomorrow will go into detail about how to write good YARA rules. And then there's a set, a set of strings, which can be textual, they can be hex, and they allow regular expressions. And so this is where the pattern matching magic happens, where you can say, match an arbitrary pattern. And so anyone who was actually at the last talk, one of the things that he was able to do was to copy paste code from other malware, modify like one thing, and it was not detected by anything. And that's the problem that YARA is intended to solve. YARA is supposed to be more generic, where you say, what classifies an entire family of malware, right? Maybe it's the decryption routine, or maybe it's a Bitcoin address in ransomware or something like that. So YARA is designed to be more generic to solve that problem. So we're looking for a tool that, since YARA is kind of the state of the art, and as you see the security community using it more and more and more, we wanted a way to apply this to the enterprise. And so we were looking for, is there a low-cost, scalable, batteries included solution that's easy to deploy and maintain that we can use in our infrastructure? And we weren't really able to find anything that met our needs, so we built it ourselves. And that is the idea of Binary Alert, where it's an open source, real-time serverless malware detection. So open source, at the end of the talk today, we're going to click the button and it'll be available to use, and we're going to continue to contribute to it like StreamAlert. Real-time in the sense that if you have all of these binaries, you need to know immediately if one of them is detected as malware. So as soon as a file is uploaded, and we'll talk about how it works, but as soon as a file is uploaded, it'll let you know within a minute or two whether an alert's fired. Serverless, there are no servers to maintain. It's not an EC2 instance running. It's not like a box sitting in a data center. It uses Amazon's serverless Lambda component, which runs in a transient container, which makes it a lot easier to maintain and a lot more secure. The attack surface is much smaller. So what are the things you could use this for. Binary alert is essentially like arbitrary file analysis. So for example, enterprise alerting, where you could imagine taking all of the binaries on all of your infrastructure. It doesn't have to be binaries, it could be any files, documents and whatnot, and uploading all of those to binary alert and getting real-time alerts when any YARA rule triggers. You could imagine forwarding email attachments to binary alert and scanning all of them, getting alerts if anything triggers. User uploads, if you have an application that accepts arbitrary user input. Anyone in security knows that accepting user input is like the #1 way to compromise yourself. So if you could upload those to binary alert, you could scan that way. And security research. So you can, because this is deployable in your own private AWS cloud, you can run this against your own collection of YARA rules and your own collection of binaries to do your own analysis without having to use a public service. So some of the features, we've kind of talked about this in the idea, but real time, again, in our deployment, alerts actually fire within 1 to 2 minutes usually of binary discovery, which is pretty amazing. So someone downloads malware on their laptop and we'll get an alert within 1 to 2 minutes. Retroactive analysis, every time you change the YARA rule set and you deploy, it will automatically reanalyze the entire corpus of binaries to see if anything new triggered. So that lets you find threats in the past with information you receive in the future. If you receive information about a new breed of ransomware, and then you retroactively analyze and you realize that you actually had that installed on a laptop a few days ago. We include some of our own YARA rules. So one of the values that we at Airbnb are going to provide to the community is we are going to provide our own YARA rules, and we also source rules from other open source projects like the YARA rules project. And the idea here is all of these YARA rules that we've tested against our own infrastructure of the more than 2 million binaries to make sure that they're effective for what we're looking for. We talked about the serverless design. I'll go into a minute about what the components look like, but again, there's no EC2 instance running, there's no SSHing. It's just an asynchronous event-driven framework. And so to give you a sense for one of the benefits of that, Lambda, the way Lambda pricing works in Amazon is you pay per invocation and you pay for how long it runs. And the benefit of that is that you only pay for what you use. So for example, 1 million invocations of the YARA analyzer with 512 megabytes of memory running for 30 seconds each, which is really long, only costs about $25. So you can imagine this is much lower cost than, say, an enterprise solution might be, or running a server where you would upload things to. Infrastructure as code. So like StreamAlert, we're big fans of Terraform, another open source project. And the benefit of Terraform is that it manages all these AWS components for you. So all you do is you run a single command that spins up all the infrastructure. It's described in parsable configuration files, which makes it easy to audit. It makes it easy to test. You can update infrastructure just as easily and so on. And finally, metrics and monitoring. Just like any production service, you need to know when binary alert is healthy and when it isn't, so we include all of that for you. It automatically hooks into CloudWatch, which is Amazon's version of infrastructure monitoring. And if anything goes down, if any component's behaving abnormally and so on, those will also fire an alert. So one of the common bits of feedback that we get is that this is similar to VirusTotal, because VirusTotal also offers a file upload service where you can scan it against YARA rules. And VirusTotal is a public service. It's designed to be something that benefits the whole community. And so there's a giant corpus of every file that's ever been uploaded to VirusTotal. And there's billions of them. And that's a useful resource. And so binary alert is not a replacement for VirusTotal so much as an augmentation, because in an enterprise, you might have files of varying levels of confidentiality and sensitivity that you can't upload to a public service. But you imagine there's some space in the middle where you can still contribute to VirusTotal. There are some things perhaps you could upload to ask to query VirusTotal for. So you could use it in tandem. Binary alert is deployable again in your own AWS account, whereas VirusTotal's a managed service. So let's talk about kind of how it works. So you have files. We all have files. And files can come from anywhere. This is up to you, the organization who wants to use it, which files you want to analyze, and so on. And all you have to do is get them into an S3 bucket. And that will start the analysis chain. So how you want to set that up is up to you. Once it's in an S3 bucket, then the magic happens. We're going to pull it into a queue, which will be grouped into batches and parallelized, sent to multiple analyzers. So each of these orange circles, that's a lambda. That's like a unit of computation. That's the serverless component I was talking about. Those lambda functions run. The dispatcher runs every minute, and the analyzers just run when they're told to. So if nothing, excuse me. So if nothing's happening, if you don't have any binaries, nothing's running, other than, I guess, the dispatcher, which is just checking the queue. But for the most part, nothing runs until you upload something. And then once things have been analyzed, if there's a match, it will send an alert to SNS, which is Amazon's notification service. And you, the organization, can decide where you want this to go. You can set up email subscriptions or SMS or what have you. We use StreamAlert for this because StreamAlert already has support for all of the different outputs you might want, Slack and PagerDuty and things like that. So the organization just defines the input, what files you want to analyze, and the output, where do you want the alerts to go, and would take care of the rest. But there's a little more we do here just to make this a production-ready service. So YARA matches are also saved to Dynamo, which is Amazon's NoSQL database service, just to have a record of every match that ever happened. As I said, we have automatic monitoring that checks the health of binary alert. Binary alert uploads metrics about its processing, throughput, and so on. Those also will trigger an alert if anything is amiss. That can go to the development team instead of an analyst team. And finally, the retroactive analysis component, where there's a separate batcher, which every time you deploy binary alert and change the rule set, it'll pull all of the binaries from your whole bucket, and files. It could, it doesn't have to be binaries. All of the files from your bucket and put them back in the queue to be reanalyzed. So that's the full architecture. And again, all of this is managed for you by Terraform, so you don't really have to worry about any of this. But that's how it works under the hood. So I figure it's most useful to actually kind of show this, and because of the nature of Terraform and so on, we can actually do this like pretty quickly. So now we need to mirror. Let's do that real fast. Where's the mouse? There it is. How does that work? There we go. Arrangement, mirror. There we go. So we have a terminal, and a virtual env. And so this is the repo that we're about to open source. And so all we're going to do, we have an AWS account here. We have a dummy email account. We have a dummy Amazon account with nothing in it. So here's S3 with no buckets or anything. And then we have the repo that we're about to open source. So here's the account. Everything, once we've got that all set up, all we're going to do is just deploy. And so what this does is this invokes the equivalent of Terraform apply, which is going to build each Amazon component, set up the configurations for which components notify each other, and so on. Usually takes like a minute or two. But if anyone has had experience with deploying production applications, a 1 to 2 minute automatic deploy like this is a pretty nice experience. So while that's going, the only part we have to do manually right now is set up the SNS subscriptions, which is of course conveniently hidden. SNS, like I said, you can set up email subscriptions or text subscriptions. So we're going to set up an email subscription. Because you have to confirm that, you can't actually automate that part yet. So in the documentation, it explains how to set up. So there it is. There's the topics that it generated. So these are the two separate SNS topics, one for alarms for the service itself and one for YARA match alerts. So we're going to say we're going to subscribe an email address to this endpoint, to this SNS topic. So email binaryalert.test@gmail.com. Create subscription. And then we're going to confirm subscription. And now we should be good to go. So that's it. now it's sitting there waiting for input. We have more than two, but we have two S3 buckets. Here we go. That were automatically created. So this one is the binaries that are going to be uploaded, and this is just access logs. So any file that gets uploaded here should automatically get analyzed and trigger an alert. So we're going to try it. And I asked my manager earlier today, I said, can you send me malware that I can put on my laptop and upload? And so we actually found Windows malware, since I'm on a MacBook. This will match one of the YARA rules that we had, that we include in the binary alert repo. So we're going to upload this. And the screen is so small I can't even click OK. So we're going to cheat, and I'm going to unplug this for a second. I'm going to hit upload, and you're going to believe that I did that. And I'm going to put it back. Okay, so we uploaded the file to the bucket, and literally in the time it took me to do that, we already got an alert that said this MD5 matched this YARA rule with this metadata, the Mimikatz credential dump tool, which is just a Windows, sort of a Windows pen testing tool that's on GitHub. So just like that, that's it. So we have this running and files uploaded to S3 trigger alerts, which is pretty awesome. So that's pretty much it. Now we are going to, so like I said, we're committed to supporting this in the future, like StreamAlert. We'll continue to support the repo going forward. A lot of open source projects kind of fall on the floor if they don't have sufficient support, and we at the Airbnb security team are dedicated to supporting it. So congratulations, everyone, on being here till 8 p.m. on a Tuesday. I'm the only thing standing between you and a night in Vegas, but you get to witness the birth of our newest public repo. Right. And I have one password, and that's not even set up on this laptop. So I guess I'll have to do that right after. But yeah, this will happen in just a few minutes. Bring that back to here. So I don't know if we have, I don't know what time it is, but if we have any quick questions. There's also a blog post coming, which should be up tomorrow. So yeah, we upload all of them. What we basically have is a pipeline where as soon as binaries are detected on a machine, that's the part that you have to set up yourself for now. And then we upload them to S3. So you can imagine OS Query from Facebook, their open source project actually has file carving capabilities. So however you want to get the files into S3, but yeah, we upload everything. Which is pretty cool.
You quoted.
Oh, sorry, yeah, I'll repeat the question for the recordings.
Great. You quoted $25 an hour or a day. Does that include all those services in AWS you had? Is that all inclusive?
Not quite. So exactly, and that's a good point. So the $25, that's the current pricing for running 1 million invocations of an analyzer Lambda function. Obviously, yeah, all of these components, there is a little bit more cost to them. So the S3 bucket being the biggest one, if you have 10 million binaries and you're uploading all of them to S3, there's a cost associated with that. But that would be true with any service. So here what we're saying is the computation cost is significantly lower than if it were being analyzed by a running server. But yeah, there are costs. Amazon actually has a free tier, and in most cases, a lot of this will actually fall into the free tier, including Lambda. Lambda gives you, I don't want to quote a number, I'd have to look it up, but they give you a certain number of free invocations. So for a small company or a small organization, you might actually be able to run it for little to nothing.
Have you tested this out with Suricata, any kind of file reassembly, then upload testing from there?
Sorry, say again?
the TCP and file stream reassembly in Suricata, pushing the files to a memory storage engine and then putting that as part of a pipeline to push up to your service?
Oh, so yeah, again, it's up to the organization exactly where you get the files from. So you could imagine, like, yeah, actually pulling them out of memory. I can't comment on exactly how we're doing it right now, but the simplest solution would be to just pull them from disk as soon as it hits disk, say, like in a production server, that you would just forward it to S3. But yeah, there's a lot you could do here. Like if you have a good way to pull things out of memory, you could dump them in S3 or email attachments or so on. Hopefully in the future, we might be able to support like specific methods of getting files, but we at least have the analysis part down.
Nice.
Any more questions? Okay. Thank you, Austin. Thanks a lot.
Thanks, everyone.